Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 581, shortest unsorted continuous subarray. Given an integer array nums, you need to find one contiguous array subarray such that if you only sort this subarray in non-decreasing order, then whole array will be sorted in non-decreasing order. Return the shortest such subarray and output its length. So they are asking to find the smallest length, the smallest continuous subarray which we can sort it so that we can get everything in the sorted array. Okay, so just see this example: 2, 6, 4, 8, 10, 9, 15. So from this, if I sort this from 6 up to this 9, then it will be sorted, right? Then it will be like 2, 4, 6, 8, 10, sorry, 9, 10, 15. So it can be sorted. So what is the length of this? 5. Okay, now see here, it is already sorted, so it is 0. Here it is already sorted, so it is 0. Fine. So how to do this? So the simple approach to do this is, first of all, we want to know about a subarray, right? Before entering into this. Okay, I will give a quick recap on what is mean subarray. So subarray is something like, it is a continuous part of an array or subset of a main array which is in order and also which is contiguous in nature. Okay, from this array I can say 2, 3, 5 is a subarray, 2 alone is a subarray, 4 alone is a subarray, 4, 6 is a subarray. I cannot say 5, 6 as a subarray or 3, 5, 6 as a subarray. I cannot say like 3, 2 as a subarray because it is not in order. Now hope you understand what is meant by subarray. Okay, fine. Let us understand how to solve this problem. So we want to find all possible subarray. So generate all subarray. For this, I will give the video link in the description. Just go and watch how to generate all subarray. Okay, fine. Now what is the second step? The second step is such that we want to find whether if we can sort that. If I sort that subarray, that particular subarray which is generated, then I want to check whether it is the whole array is sorted. If it is so, I want to take the minimum among all. So it is a brute force approach, and it is a simple approach too, but it is more complex than the optimal one. I will tell you how to do the optimal one. So its time complexity will be O of up to, it goes up to n power 4 or 5. Yes, n power 5 it goes to. Okay, and what is its space complexity? It is O of 1. Yes, otherwise it may be go up to O of n if you store in an auxiliary space. Okay, so it is very huge. Yes, so how to optimize it? Actually, according to ourselves, basically understanding the optimal is quite harder than brute force, but here understanding the optimal is much better than the brute force. Okay, so try to write the brute force for this problem because it is quite harder than writing the optimal solution. Okay, fine. Let us understand how to do this optimal solution. Just see here, 2, 3, 10. Okay, up to this it is increasing order. Here 20. Okay, but here comes 15. No, I cannot get this 15 here because it is in increasing order. Okay, so I cannot get this. Okay, fine. So it is the starting point. It is a starting point. Okay, then I cannot get this 17 also. I cannot get this 21. No, I may get, but see here it is 15, 17. So I want to go to this 20 also. Then whether this 10 is at the correct place because all in the right hand side is greater than this 10, right? But this 20 we have 15 and 17, so stay here. This 21. Okay, fine. This 21 will also be included because this 15, 17 will move to right hand side, right? Can it? No. This 21 is the correct order because in left side this 21 doesn't have anything which is larger than that. Okay, but again 19. So obviously this 21 should be rearranged somewhere in the right side. Then again 20. Okay, 20 will be also rearranged so that this 21 comes here. Okay, 13. 30. So all the left things are less than the 30. So I can say these are all the elements I want to sort such that I will be get the array as sorted. So this is a minimum number. So 1, 2, 3, 4, 5, 6, 7. So up to 7 numbers. Fine. So this is how we want to see this problem. Okay. The better way to understand this problem is, let us take an example. Let me take this as an example. 2, 3, 5, 4, 6. 2, 3, 5, 4, 6. Okay. What we have done before, we are just checking what is the correct position, right? For this 20, I want to check whether all the right hand elements is greater than 20. If it is so, it is at the correct point. For this 15, I want to check similarly. And if for this element 30, if everything in the left hand side is smaller, then it is in a correct position. For this 13, it should be second largest, like that. So it is basically, we want to do a sorting. Can you understand this? By using the sorting method, we can find what is the exact position of each and every element, right? So first I am going to do a sorting. Now I will know which are the elements that are not in my correct position. So see here, these two elements are not in the correct position. So just return 2. Simple, right? Okay, let me take any other example. 2, 1, 10, 20, 13, 21, 30, 40. Now, if I sort it, it will be 1, 2, 10, 30, sorry, 10, 13, 20, 21, 30, 40. Now tell me which are in the correct position and which are all in incorrect position. So these are all in the incorrect position. So I want to return what? 1, 2, 3, 4, 5. 5. Fine. So what is the time complexity? I can say time complexity will be O of log n if you do in a merge sort, and space complexity will be O of n if you do the merge sort, or else if you do the normal sorting, then it will be O of n square and space complexity will be O of 1. That's it. Much more optimized, right? No. In this also we want to have a auxiliary, because we want to store this in a auxiliary space and we want to compare these both. Hope you understand this. Okay, so this will be the optimal one, n log n and the linear time of space. Okay, fine. Let us see the code in Python first, then we can see a slight modification in this problem and see the code in C. Okay, so it will be more syntactical. Okay, fine. So see here, first of all, I am taking a copy of this nums and storing in ARR. Now I want to sort this nums and then I want to take the result as 0. Now f and r is equal to -1 initially. Now I am just go on iterating one by one. Now if nums of I is not equal to ARR of I, then what should I do? Then if f is equal to -1, then what it signifies? It signifies that if f is equal to -1, then there is no first element which is not equal. So it should be the first element which is not equal. So I will store in f. Else I can assume that already f is storing some other element. So I want to store what? In a second value. Okay, see here, if this is the scenario, let me take any other color. Okay, if this is a scenario, first of all I am here. Okay, now whether these two are same, no, then there itself I will store f as 0. Then I will move and check here. So whether these two are same, no. So now I will continue and store in R. Okay, then come here. Here it will be 2. Now it will be 3. Now 4. Then this is equal. So don't want to do anything. So finally, if I do 4 minus 0 plus 1, it will be 5. Can you understand this? So this is how I am calculating here also. Okay, then at last I am just returning what I done there. And just see here, we can do this in some other ways, like, yes, I can also do like this. It also work. Okay, I'm just checking whether f is equal to -1. Then I want to update in f and also in r. If it is not so, I want to only update in r, the last position. Okay, so by doing this, we don't want these conditions. Now the code is pretty concise, right? Okay, Let me submit it. Yes, forgot if f is not equal to -1, else we want to return 0. Yes, it is submitted successfully. Now we can see in how to do this in a C programming. See here, this is a C programming. Now int main. Now see here, first of all, I'm just taking 3 variables and I'm printing it on the array size, and I'm just getting the value, and I'm just getting the array elements and storing in the temporary array also, because we want to do sorting and store in a separate manner, and we want to take the original array, right? So I'm taking the temp, and now I'm sorting the temp using a sorting algorithm. Now int result of 2 is equal to -1, which means -1 and -1, like we saw the f and r, right? Here I'm just taking an array. Okay, now if array of I is not equal to temp of I, then what should I do? If result of 0 is equal to -1, then I want to add into this else. So here also I done the same code expansion I done in Python also. So here it will be not else, it just take here, and here I want to check whether if my f and r, so result of 0 is equal to -1. If it is so, then I want to print what? Then I want to print 0. I want to print 0. That's it. So it means that we don't have any starting point or ending point, or else you can also leave as it is. Then it will print what? -1 and -1. That's your wish. Your wish. Like I want to tell you, like I will explain with an example. 5, 1, 2, 4, 3, 5. Then it is like 2 and 3. 2 and 3 means what? This 4 and this 3. So this is the indices, right? Starting index and ending index. I am just telling you, like we can also do like this, so that it will be printing only 0, like else, in else part. So you don't want to bracket. Now it will print -1, so it will be more meaningful. Yes, hope you understand this, right? Okay, fine. So this is how you want to do. Thank you.